Hello. Yeah, that sounded a very grand sort of introduction, but I've sort of spent more of my time when preparing for this presentation, which I've done several times over, and Michael was sort of taking the mickey out of me yesterday because he could see me preparing my presentation yesterday. Actually, I was revising it, and I was up again at 4 o'clock this morning revising it again because I don't really want this to be just like, this is my research and isn't it wonderful. I want it to be a little bit more challenging in terms of thinking about where we've been, where we want to go, because I think it's really important to think about that. In fact, actually, I'm already on sustainability. Michael's thinking, oh God, he's already off task. It's only like 1 minute in. But I did just see this yesterday on my email. One of my colleagues has sent me their new paper. And it just shows how important it is really to make sure that the research is going in a particular direction, because it costs. If you have a research or indeed a whole field that is not correctly oriented and is not working efficiently to actually get what it wants done, that costs money, it costs time, it costs energy, also costs carbon apparently, because failure to self-correct, the failure of research to self-correct, in other words, this association between this particular transporter gene and anxiety and depression has been well and truly disproven, but the research is carrying on. And my colleagues made a calculation of how much that's costing in terms of carbon, which apparently is the whole of the carbon footprint of the University of Bristol in 1 year, or driving a medium-sized car nearly 90 million kilometres, which you wouldn't really want to do, would you? But it's also the time, the energy that we put into these enterprises. And we've already put a lot of time and energy into this enterprise that we call neuroscience and education. So this is a little bit indulgent. I tried to map out very briefly to myself, which is the small print, some of the important milestones in the development of this field. And I'm going back to the 90s, actually, sort of late 90s, when Uta Frith and various other people, Guy Claxton, Sarah Blakemore, I can't remember all the names. I think John Stein might have been in there somewhere. Got together, I think it was a sort of a Royal Society initiative to talk about this idea of using findings from neuroscience to improve education. And that then, you know, that gave rise to some pilot projects, of which mine was one. I think that review was published around about 2000, so we are going back 25 years. And when things just started off, I was actually a teacher in Rolf Allen's school in Bath, and I sort of go back to those times and I'm thinking, you know, it's a rainy Friday afternoon, I've got year 9, double period, what am I going to do? I haven't got much time to prepare because I was too busy last night marking. All those other concerns, I've got some reports to write as well, and there's that kid who's always giving me Jip in the front row, should I move him to the back, all those sorts of things. And yet, actually, even then, I have to admit, I was thinking, how does learning occur? What's the professional basis of this profession? How am I supposed to know what's effective, what isn't effective? And I used to bunk off during the lunch times and go to Bath University, which is in the same road, go into the library, and I was reading books about parallel distributed processing and psychology. And at that time, I didn't have a psychology degree even. I had a degree in nuclear engineering and a PhD in medical physics, but I didn't know very much about psychology. So along the way, I picked up a degree from psychology from the OU, and I started using fMRI when I was actually training teachers, so that was pretty bizarre. I don't know if anybody understands the environment of a teacher training institute, which had no research record whatsoever, and there's this guy sort of putting people in brain scanners. It was a very odd time, and I do believe I was that close to getting sacked, honestly. And if I hadn't gone to the University of Bristol, if they hadn't invited me and said, actually, you're doing something worthwhile, come over here, I think I would eventually have got the sack. Because they were just very uncomfortable with this idea of neuroscience in education. And then I studied some stuff on neuromyths, which drew a lot of attention to me, which was much easier to publish, I have to say, than the fMRI studies. More fMRI studies, lab studies, classroom studies, And then, of course, when the Wellcome provided this very generous funding of 6 million to do large-scale school trials, I was lucky enough to gain one of those grants. And I had my first experience of RCTs, but also the experience of having those RCTs politicized, if you like, because there was an awful lot of control. I wish I'd fought as hard as Michael did, I have to say, I don't know, in retrospect, against these ideas about how RCTs and about how research in schools should take place. But never mind. I learnt a lot from that, which I'll touch upon a little bit later. And then I guess a lot of things have happened, but I'm more focused now on communication efforts and experiments to do with communication and trying to understand how we can get this knowledge to educators. 2010, I produced this book, which I think was one of the first textbooks in the area. And it was kind of like my map of how I thought things should work. You know, blank sheet, what should neuroscience and education look like? And I built off this idea of Uta Frith's and John Morton's, this idea of brain, mind, behaviour, this sandwich. And I was keen to have the social sciences in there somewhere. And I could see that cognitive neuroscience was very good at building these links between brain, mind, and behaviour. And the behaviours, of course, that we're most interested in as educators are learning behaviours. But I also thought, okay, this is a kind of a social thing as well. So it's kind of like having two brain, mind, behaviour models at least talking to each other. And in the middle, we have this sea of symbols that have to be interpreted in some way to make things meaningful. And that's what the social sciences are particularly good at. Whereas the natural sciences, of which I tend to feel that cognitive neuroscience is one really, are very good at building those links, a bit more at the individual level, I would say, between brain, mind and behaviour. But we need to have this whole picture of what's happening in the classroom. And this sort of brought me to becoming a critical realist, and I'm sort of laying out my creed now because I think it's important that I know a lot of scientists look at philosophy and think, don't do that. I just want to do my experiments, test my hypotheses, but actually it can get you into a lot of trouble if you don't get your philosophy sorted out. And I believe in a single objective reality, and I think that that's really important in this post-truth Donald Trump sort of a world, which is quite, anti-science at times. It's important to stand up for the idea that there is actually a single objective reality that is governed by causal mechanisms. But I also believe that we will never fully grasp it, and that is also important. But this single objective reality gives rise to actual real events. Some we observe, some we don't. And then there's also our experience of those events, including our attempts to capture data from those events. So we're quite a long way, actually, from that single objective reality, but it's there, and we want to be tethered as closely as we can to it, and that's what science does for us. And we have to stick up for it. And I'm talking about natural science chiefly here, because social science quite often has perspectives where they believe in multiple realities. And I think that's interesting, but I would challenge that. Nevertheless, social science is very good for catching meaning and interpretation. We have to use that meaning and interpretation to understand the significance of what we're doing and to communicate with each other. So I believe that these two perspectives are very important together in order to get a model which is the most closely tethered to reality that we can have. And I also noticed when I was in the preparation for this book that there's three types of evidence that we perhaps should be interested in. We have the social evidence, which is what teachers tend to draw off most of the time. And in fact, in the laboratory, when we're making measurements of behaviour, I would to some extent call that a social response, because you're having to interpret, even as a scientist, what that behaviour means. But we also have the biological evidence, where we can actually see increases in blood oxidation level signals, for example. And that is very important because that's another source of concrete evidence in addition to behaviour, which is why cognitive neuroscience is so important for education. It's why it exceeds the threshold, if you like, of what is important and what should be included in our ideas. It exceeds the threshold that's set by just psychology on its own. Of course, psychology is really important. It's at the heart of cognitive neuroscience. But cognitive neuroscience adds that extra dollop of concrete evidence to tether us to that reality which I happen to believe in. And then we also have the experiential, which actually is really important, but it's easy sometimes for us to forget about it if we're taking a natural science road. It's only at the experiential level that we can really talk meaningfully about things like free will, and free will is really important to educators. And neuroscience is rubbish at studying free will. I'm sorry, but when a neuroscientist starts talking about free will, well, first of all, it doesn't happen very often. When it does happen, it's usually tied up with consciousness. And where is that taking us? Does it even exist? I mean, so I think experiential perspectives are really important from that point of view, and they need to be honoured by educational researchers as well as cognitive neuroscience researchers. How does it feel to have this learning experience? What do you feel is going on? Nobody can tell you that, really. It needs to come from the words of the person themselves who's experiencing it. And then I also noticed that, my aims, what are we trying to achieve? Well, I thought we're basically, and you might wish to disagree, but 2010, I thought we're trying to further educational understanding and practice, and we're trying to further scientific understanding. And if we're going to do that using these three forms of evidence, then maybe we need three types of study: scientific studies, bridging studies, practice studies. Practice studies to tell you actually how to do it in the classroom in the best way possible. Scientific studies to make good the principles. The bridging studies, pseudo-random experiments, perhaps sort of passing between the two. It all gets a bit complicated, but I was thinking, well, okay, you've got these three forms of evidence, lots of different ways of actually collecting data that contribute to these different types of methods, very diverse from fMRI to grounded theory. Some of you are saying, what the hell is grounded theory? It's a qualitative educational sort of thing. Building up to these three types of study that together can serve these neuroeducational goals, or educational neuroscience, or whatever you want to call it. It's all in the book. You don't have to photograph it. And I followed this to a large extent in two areas. One was creativity, trying to find out how to foster creativity. We're doing laboratory studies. How many ideas can you think up for this object? fMRI studies, which also included some concerns about ecological validity. So we were comparing just how people behaved in a confined space. That was very low-cost studies using a £50 MRI scanner made out of MDF from B&Q. Thoroughly recommended. But actually, amazing, that was borrowed by so many scientists to do preparatory work for their imaging studies. Also, even performative methodologies, working with actors and artistic directors. This is creativity after all. How does it feel to the actor to be using some of these strategies? And then trying them out in the classroom as well. Also with gamification, similar sorts of approaches, trying to use all these different types of methods, pulling it together into some sort of holistic understanding, but by using these different methods, being able to interrelate them, producing messages that could appeal to different audiences, different types of evidence, fMRI studies, classroom studies, laboratory studies, also producing an app, Oodloo, which is thoroughly recommended. I love the fact that Usha's work makes people sing. I thought, that's great. That's great. This thing makes people scream. I used it. I'm not sure if that's better, by the way. I'm not suggesting it is. I think I prefer the singing. But it's great if you go to this site, Oodloo. There's only one whole gaming app on there, whole class gaming app. And it basically employs this understanding of the brain's reward system. And you get students learning at the same time as they're screaming, because they get so excited. I used it this week and had 150 PGC students shouting the house down. My reflections along the way, and I think the question is, how much of this has changed, really? Many educators are very open to learning from neuroscience. It is still the case. They are very open to learning from neuroscience, I think, educators. Of course, with the move towards academies, I think, there's some advantages there because it means that the schools and the educators themselves can be drivers. Educational research culture is wary of science and scientists, and I know a lot of us have had some experiences of this. Me too. Painful experiences. Have things moved on? A little bit, perhaps, because we do have here and there, we've got some educational researchers who are actually doing educational neuroscience, so that's kind of helpful. But it's still there, I would say, a distrust of natural science as, in educational thinking. Neuroscientists are publishing books on how we learn. Still happening. Can't find any, and this is the really nub of the issue, really. I can't find any books on how we teach written by neuroscientists. Why not? It's been 25 years, people. 25 years. And still, there seems to be little evidence of educators informing practice with the science of learning. It's interesting we're calling it science of learning, isn't it? It's sort of moved to sort of this broader sort of title now, including findings from neuroscience. And teaching to learning styles and brain gym live on. How can that happen? I was sitting there today, I was thinking, I better make sure that's true. Oh yeah, it's true. In fact, I think there's probably more videos on brain gym now than there were when I last looked. Why are we doing this then? Are we doing it because we want to understand, we want to diagnose learners better, more accurately, and understand their needs? Are we trying to validate? Or are we trying to challenge existing approaches? And that's sort of like saying, is this about what works in the classroom? And I think there's a lot of concerns about this idea of what works in the classroom. Because actually, I think practically anything can work and anything cannot work, depending on the way in which it's implemented. Innovate, are we trying to innovate new approaches? Well, okay, but, maybe we are, but do remember, people, that I think you can take a bad approach like brain gym, and I've seen it being used by a good teacher very effectively and actually contributing to the learning in the classroom, even though, and this is why I'm slightly wary, it is in my personal opinion, and I'm not presenting it as a scientific fact, that brain gym is bonkers. And yet, educators can actually make it work, just as they can take your very good scientifically grounded ideas and do them ineffectively in the classroom and have no effect or maybe even a negative effect. So are we instead, hoping that we are trying to provide insight into more everyday teaching, as well as maybe specialist teaching, to develop it and improve learning? I think possibly we are, as one of the things, I'm hoping anyway. It seems a good idea because when teachers know why they're doing something and then understand how it works, then there are implications that are going to impact on their practice. So something like daily revision, it's kind of established in the sense that lots of studies, on average, have shown that it works. But I'm sure that you can implement it badly, and I'm sure anyone is a teacher trainer, and we've got some teacher trainers with us, we've seen it implemented badly. We know it can fail. So how do you implement it well? How can you improve the implementation of it? Well, if you understand that it's about rehearsing knowledge, it's helping to monitor learning, it's also priming prior knowledge, and that's happening through building up multiple representations. It's about new building on old, the fact that younger learners actually have more difficulty scaffolding on top of prior knowledge. That actually has implications. Maybe you want to be doing that revision using new contexts, encouraging that transfer. Maybe you want to be using novelty to try to engage the learners more, because we know that activates the reward system. Maybe we want to have a focus on those concepts that are going to be foundational for the learning that you're actually using this lesson, if you're hoping to prime it. It has implications if you understand why you're doing something. So it's really important, I think, that teachers have this knowledge. So what knowledge am I talking about? What is the science that's most important? I've spent some time working with others, working with a team of people to identify those scientific concepts that have most educational relevance they have scientific validity, they could provide a good foundation for more complex issues such as ADHD, dyslexia, dyscalculia, and it also can provide some holistic understanding about how learning happens in the classroom, because at the moment we have the early career framework, and that's another sign of progress, because we do now have words like working memory and schema, long-term memory, in the mandatory training for teachers. That's great. Unfortunately, what it doesn't do is encourage people to provide some holistic understanding to teachers about how learning happens in the classroom in terms of underlying processes. It doesn't do that. So that's why we actually train our teachers using these concepts, and I'm really pleased that I'm seeing textbooks. I've just been handed another one actually, but this one, I've just handed this one, so I've just been handed 2 textbooks today that are drawing on these concepts. So well done, Bath Spa University. Interesting, and I was just saying to my colleagues from Bath Spa, it's really interesting that that's how it's travelled. It hasn't travelled through the internet. It hasn't travelled through academic journals. It's travelled 7 miles down the road to Bath from Bristol. And what does that tell you about how we need to disseminate our understanding about science? You know, it's actually, it's anyway. Okay, just leave you with that one. If you want to know more about this, there's the website. Lots of free stuff on it. So we incorporate it into our teacher training. We have like 10 basic scientific concepts, and you can deliver those in like 20 minutes. The hours that we have with teacher trainees, and we only have about 4 hours, but on a PGC, that's a lot actually. I'm very grateful for them. It is all about applying those to the practice, because the science is a very, very small part of the amount of thinking that needs to be done in order to apply it in a real world classroom, because of the amount of adaptation that needs, and the differentiation and the responding to individual students, but also just for teachers to get their heads around the science. And that's really, one of the points that I want to get across is that it's difficult. We've also trained up the mentors as well, so that when we go into the schools, the mentors understand a little bit about the science of learning. And in fact, there are videos of mentors debriefing. These are the people in the schools, the teachers in the schools, debriefing their students and using some of these concepts. But yeah, this is the point. It's actually really difficult. This is not straightforward at all. I mean, for one thing, initial teacher training and continuous professional development is difficult. For example, where is the evidence that actually professional development has any impact on student learning at all? It's pretty tricky to find. That's how difficult this is. And I'm not talking about science of learning, I'm talking about any professional development at all, producing improvements in the students' learning of teachers, from teachers. Lots of other things make it difficult. This college practice divide, that for some reason, whatever you tell students in the lecture theatre doesn't seem to travel to the schools once they get to practice. We also have these cultural issues, which are not straightforward at all. The DFE to some extent is still embedded in 1980s cognitive science, and I'm not sure what we can, well, judging by the early career framework anyway, I'm not sure what we can do about that. Something that needs to be done. But Ofsted, they're a bit stick in the mud really. They're not always very helpful with this. So there's a lot of cultural issues that make it difficult, but also, of course, something identified right at the beginning of this enterprise: language, concepts, complexity, very different to the types which are encountered in everyday life or in education more generally. We have different professional aims as scientists compared with educators. And there's always this neuromyth potential. I mean, there are some people who say you shouldn't bother with neuroscience in education because it just produces more mumbo-jumbo. But what are the alternatives? Really, what are the alternatives to getting involved with teaching? Because I want you to get involved with teaching more and teachers. That's what I'm asking for today, really. Well, you can do some things. For example, like I did, you can produce apps. But the idea of sitting a child in the corner of the classroom or getting them to use something at home with their homework and an app and things like that is limited. that's not going to really change the educational experience of children greatly. The people who are changing the educational experience of children, the people who have the potential to do that, are the educators, are the teachers, are the schools. We can provide books for students about their learning. We seem to struggle providing books for teachers about teaching. We can produce resources, but I don't actually believe there is any alternative. If we want this field to progress, this educational neuroscience field, we have to engage more with teachers and with teaching. Why is it so difficult? Well, let's look at it from a psychological point of view. This is a paper that I published with Centre for Early Maths Learning, where I was asked, and I was quite happy to do this, to review the research that we have on how we might encourage teachers to take up research findings. For one thing, you've got to grab the teacher's attention. And this is these are things which I think all of us as researchers, all of us as researchers should be thinking about at the beginning of the research project, actually. Put it into the plan. How are you going to actually grab their attention? Things like video, really important, especially if you've got a project where you could use some video data anyway. It's really helpful when it comes to promoting. But the other thing is they've got to understand, even if you've got them engaged, and this tends to be the area where there is most research done or most evidence is actually generated of researchers doing something about communicating with teachers. It's this point here, it's engagement. So we've kind of got this covered to a large extent, but I'm sure we could improve. And by engage, I mean holding their attention, so they actually know the research exists. That's the first step. But then if they know it exists, actually, what's it about? They've got to understand it. And there are all sorts of issues with language, communication, conceptualizations, the way in which it's building on what they already know as well. Things can become very distorted. The number of times I've tried to explain something to somebody about the brain, a teacher, and they've said, oh yeah, no, you're right, aren't you, Dr. Jones? That's right, because that's all about learning styles, isn't it? No! But they will automatically connect to the things they think they know. But then even if they understand it, will they value it? Because remember, there's an awful lot of other things that they've got going on, priorities. Will they think it's actually important enough to do anything about? What do teachers value? We have very little research on that. What causes a teacher to want to get out of bed in the morning and go to school? The very little research we have comes more from primary school years, where it's very clear that this idea of well-being of children is very predominant, and actually trying to nurture and foster the well-being and the development and the happiness of a child takes pole position. It's the top position over learning and education. But I suspect there are other reasons as well that we need to be more aware of in terms of what actually causes a teacher to think this might be worthwhile. It's not whether it works or not. That might be one issue, but it's not just that. It's whether it works in what respect, how it's going to link on to something else, whether other people value it, peer responses, social norms, all that sort of stuff. And then even then, if you really value it and you understand it, are you going to do it? Well, a big question there, for example, is going to be self-efficacy, confidence. Do you feel able to do it? Are other people going to be able to support you? Are your management going to be able to support you? Are the researchers going to be around to help you if things go wrong, or whoever? And then, even then, when you've decided you are going to do it, how are you going to do it? Because you're going to have to adapt it. Everything has to be adapted. It has to fit particular context. And of course, this is why I've got these arrows going back, because that comes back a lot to understanding. If you don't understand the principles of what you're doing, you're not going to be able to adapt it. Hardly any research on this at all, how teachers adapt. Who knows? And it's very difficult for us as scientists, because quite often we're after fidelity. The last thing we want is for them to adapt it. But actually, we're going to have to lighten up on that a bit, because that is the real world, and teachers do adapt. So let's start finding out what they're doing. And I learnt this to my pains, I've got to say. I mean, I was talking about the RCT. Did my RCT work? Well, I found out that basically, if teachers used it, yes, it seemed to start working, but unfortunately, most teachers were not using it, or they were using it in an inappropriate way, despite all the training, because we were sort of monitoring it online. So that was a hard lesson to learn. It's got to be support for adaptation. And then even then, will they actually carry on using it? Because what's the point of them using it for 1 year just to show that your intervention works? Will they carry on using it? Hardly any research on that. We don't know. So these are some of the things to think about. The paper's there, but it's also been published by UNESCO thanks to this new Global Alliance for the Science of Learning. You'll find it in a freely downloadable document there. Each of those stages in teachers' thinking in terms of whether they're going to use your research could be accompanied by some questions for you to ask yourself. This is in the document, and I suggest that you think about these questions before you set off on your research, but even if you're halfway down the road, that's fine. Even if you're a bit further than that, it still might be worth looking at these questions if you really think that your research is worth putting into practice. Because if it's not worth putting into practice, please don't do it. We've got a pile, haven't we? Haven't we got a pile of abstract knowledge? We have so much insight, we have so much understanding about learning. How much of it is being used in schools? It's a really difficult question to ask, but I'm sorry, do we need any more, actually? Is there something else that you could be doing with your time which is more profitable? I think there probably is, which is actually to focus more on how teachers might be using this knowledge and understanding. It's a very small piece of research I've done myself on one part of that, which is actually valuing. Some teachers value ideas such as a lesson must have a beginning, a middle, and an end. These are sort of common sort of rules of thumb, heuristics, I'm not even sure you want to call them that really, but ideas which teachers work to. They make you look like a teacher, so they make you look like you're performing as a teacher, but actually they don't offer you any insight into why a lesson might have worked or not have worked. A more scientific statement might be children's brain circuitry for connecting new information to prior knowledge is still developing. There's no prescription there, it's not telling you what you should do, but it does potentially offer some insight and give you perhaps some ideas about what you might do in particular contexts. And when we surveyed teachers about these, what we found was that these performative ideas, I'm pleased to say, with years of experience, they do reduce. Not greatly, but there is a relationship there, you can see. Gradually, as teachers gain more experience in the classroom, they give up on these performative ideas and realise what a load of rubbish they are. I couldn't show you a similar graph for experience for evaluating science of learning, because there wasn't a relation there, but then there's no reason why teachers at the moment, or at least when this study was done 2 or 3 years ago, should be accumulating more understanding of the science of learning through their professional lives, unfortunately. Instead, it comes through with age. It's just about how long you've been on the planet, and the longer you are on the planet, the more you're likely to start believing in scientific basis of learning as being important for how you teach. So that's kind of positive. And what we also found, I should say, because people like putting these bar charts up, actually, and it is kind of encouraging, that we just 90 minutes of professional development on the science of learning did actually cause a shift in how teachers valued the science over performative ideas 6 to 12 weeks later. So that was kind of encouraging. So we need to know more about this. As I say, we know very little about how to explore the impact of research findings on teaching, and particularly on how teaching might change in a way that actually improves learning. And we need to be doing that. We need to be showing that actually this knowledge is valued by the educational community and it's improving learning. I think 25 years down the road, we need to be able to provide that evidence. But how do you actually do that? How do you scientifically explore that relationship? It's not a coincidence that people stop at that point. It's very difficult to find evidence of where a teacher has been told something and then you see the pupils' learning improving. And still we've got neuroscientists publishing books on how we learn, not how we teach. And I think that this does limit the usefulness of the science of learning. This has to be the frontier that this field now faces up to. This is the challenge. If we don't get past this point and all we can do is bang on about learning, we are not going to be valued in the way that the science should be valued. A teacher will ask a scientist at some point, well, what do I do with the science of learning, with understanding this learning? And how would you know anyway? For example, how does the science of working memory guide teaching practice? Well, yeah, it can inform a teacher's planned and in-the-moment decisions and reflections, all of these things, but it can't tell a teacher how to teach. The way that science of learning informs teaching is complex because teaching is complex. There's no prescription. And partly that is also due to the fact that the science of learning is a little bit incomplete. Possible responses to complexity. Well, one thing we could do is just say, let's just keep science of learning out of education for the moment, right? Because if we're not going to do this, and if it's not fit for, if we haven't got the knowledge of how to communicate to teachers, we haven't got enough knowledge about teaching, maybe we should just keep it out, And I'm sure that those who are worried about the scientisation of education would appreciate us doing that. I actually had to, I'm not keen on it. I can't imagine medicine without biology. I can't really imagine why education would benefit from not having a scientific basis to what it's doing. But this word scientism has sort of been cropping up more and more in the educational literature, and I hear it reflected back at me sometimes. And I had to look it up in the dictionary yesterday because I thought, what does it actually mean, scientisation? I thought if it just makes it more scientific, then I'm kind of keen on it. I think I want to scientise education. So I looked it up in the Oxford Dictionary yesterday, and it said, a thought or expression regarded as characteristic of scientists. Good. But then it gives you a second meaning, excessive belief in the power of scientific knowledge and techniques. Okay, so that's the nub of it, isn't it? Basically, if we start talking about the science of teaching, and we start understanding, the psychology and the neuroscience of teaching, are we going to be accused of being excessive in some ways? Well, personally, I don't think so, but that is the criticism. I would like to see a science of teaching established that can use experimentation to build a progressive body of scientific knowledge about how teaching impacts on learning. We've got working memory. Actually, what was the point of that? Hang on, I'm not quite sure why I've written that there. It's got to align with and inform and build upon the science of learning. It's got to be educationally relevant, scientifically valid. It must not be seen to be generating science-branded prescriptions. It's something we're going to have to struggle with very strongly because there are lots of people who want a fix-it-now, this-works solution. We have to continually work on that. It's not going to go away, that problem. We also have to embrace, examine, and evidence teaching as a richly diverse and complex activity. Why? Well, because it is. And I think the scientisation lobby is worried about reductionism. But in an experiment which I will briefly show you, you can actually use laboratory experiments to demonstrate this richness, this diversity, to make friends with educators, not drive them away in this belief, false belief that we're trying to reduce what they're doing. And apart from anything else, we need to get the debate going. I'm impatient now. I'm an old man in a hurry. We need to get this debate going. If we don't want it, why don't we want it? What are people frightened of? It would address many questions that actually, we haven't addressed up till now, but actually educators haven't addressed up until now either. For example, how do everyday teaching behaviours impact student learning? I know it sounds simple, but how does teaching affect learning? Nobody knows. How can that be possible? How can that be possible in 2025 that we don't have studies that really show how teaching affects learning. I mean, I know we've got lots of intervention studies. You do A or you do B, you see a difference, right, okay, but that's not teaching. Teaching is when you have a freely willed agent, a teacher, going in spontaneously a lot of the time, responding to learners because learners are spontaneous, and we've got no way of relating that to the learning that comes out of the classroom. How can that be? Education really needs our help. Because if they haven't got that data, they need science, and they need it quick. How do teachers' how does a teacher's understanding of learning influence their teaching behaviours? Well, once you've got that relationship, if you give concepts about science of learning to a teacher, does it affect what they do, and does that then affect the learning that's coming out? And of course, you know, I know all of you, a lot of you are very interested in one particular aspect of learning, and that's fine, because you could apply this question to that one particular aspect, you know. I mean, if you're particularly interested in how use of fingers or understanding the role of fingers in mathematics cognition, if that's your thing, then how does telling a teacher about that affect what they do in the classroom, and how does that affect the learning? What happens in that pipeline? How does their experience, their education, their cognitive function of the teacher, how does that affect their teaching behaviour and then student learning? And a simple question, which you think might have been answered by now, if you're a good teacher of geography, does that mean that you might be a good teacher of science or a good teacher of mathematics or some other thing? Do pedagogical skills, do they actually transfer? Because as a teacher, when I was in D&T, oh, Paul, actually, we haven't got anyone to teach Year 8 history. Would you mind? Happens all the time. Out of field teaching. We don't know, actually. We don't know whether it affects it or not. There are some methodological barriers. I mean, one problem is actually categorising teaching behaviours. If you give people a tick sheet of established good teaching behaviours, when you tick it, you're not going to find any relationship between that and the learning that's achieved in a class. Okay, so we need something more scientific, more carefully thought out. One of the things that we did in our experiments, where you've just got a 15-minute teaching, very, quite sort of synthetic, simulated sort of teaching situation, was to do an interpretive analysis deductively framed by the science of learning. In other words, we're saying it's this specific learning goal, let's look at the teaching behaviours, and then knowing what we know about the science of learning, how should we categorise these, and then see if those are actually predicting learning. And of course, you need a task which teachers won't say, oh, that's completely nothing like a classroom. You need something that looks a little bit realistic. So what we did was micro-teaching, which is seen as an established means of developing teachers' ability, where people are randomly allocated to be a teacher or a student, a bit of pre-test for the student, preparing the teaching for the teacher, about 5 minutes or something ridiculous. 15-minute teaching and learning session, 10-minute break for the teacher, post-test for the student, swap over, and do it the same with a different subject. You might be teaching Swahili there, and you might be teaching Finnish there. There they are, doing their thing. I did it online. It's one of the effects of COVID. You suddenly start thinking, what can I do online? So this is a new experience for me. But what we found is when you start categorising teacher behaviours in that situation in terms of engagement, disengagement, building of knowledge, consolidation, those categories I was talking about before, you do find that actually explains the learning, that explains the variance that you see in the learning scores. So you can actually find a relationship between teaching and learning. Hurrah! This is really important because we didn't really, we constrained the teachers to some extent, but actually they could do anything they want, and they did some pretty weird stuff, let me tell you. Pretty weird stuff, some of them. But also, you can look at the teaching behaviours qualitatively, and you can categorise those teaching behaviours. And what I've done here is that these are sets of teachers exhibiting at least one instance of a subcategory of behaviour. And when you sort of put teachers into these sets and the intersection of these sets, you find that they're very widely distributed. So for example, wherever there's a 1, it means that that teacher here was uniquely defined, since there's only one of them, by that combination of first instances of teaching behaviour. So, 15 minutes, and yet they are most of them are uniquely defined by their teaching behaviours as a result of our analysis. It's very, very rich. Okay. Interestingly, the sort of results that these throw up, we didn't find any relationship between the number of years of experience of the teacher, even though it was a language task and these were language teachers, all except one. Didn't find any relationship between the experience of the teachers and the outcomes in terms of the learning of their student. And so I think there's some questions to ask there, perhaps. And there were some things about our theory which needed to be changed. So this is actually a useful experimental sort of approach whereby you can develop a framework for understanding teaching. And then when you've got that framework, you can tweak it a little bit and do something with the teachers, such as some professional development on the science of learning, and see how that affects things. And for what we did, we had a little conversation, and based on our conversation, we were able to sort of identify whether they were engaging, whether they understood, whether they valued, whether they're committing, whether they're adapting, using those categories, those cognitive categories of how teachers take on new knowledge. And you can see that there's a pattern forming, but we didn't get enough funding and a big enough sample to be able to make this statistically significant. But you can sort of see that when you order the teachers in terms of their learning improvement, so this is like, you might say, the best teacher, and that's the least successful teacher, you also see there's something going on in terms of whether they are passing through that cognitive pipeline, that logic model, of how they're getting on with this new knowledge. So we did put in for some more money, but the reviewers didn't like it. And I think this goes back to this fact that educational research culture is very wary of science and scientists. And I don't want to get to, because I've only got 1 minute left or something ridiculous. But you can see, this is like 25 years on, there's a horrible sense of deja vu here. Scientization crops up quite a lot. This idea, you can't use science to understand teaching. Well, rubbish. I think that is absolute rubbish. I think we need to move forward. That is our frontier that we need to be facing up to. Because only then will we really have the relevance in what we do, and also have the language and the relationships in what we do to ensure that the findings we've got are actually going to get into the classroom and do something in there. And I have to say, all of these criticisms could also be applied to science of learning research, but they're less worried about that because you guys are going to stay in your boxes looking at learning. So you're safe there. I'm saying you need to get out of the box and start talking to teachers and I know a lot of you do talk to teachers, but get a bit further than that and actually start researching the teaching of what actually goes on when you give your findings to teachers. So are we ready for a science of teaching? Well, it's possible, and it's potentially valuable, I would say, because you could use tasks like that in FNurse. And in fact, I saw a great poster yesterday from Imogen Green. Is she here? Hey, well done. Where you've got the teacher wearing the electrodes, and it wouldn't be, I can imagine redoing that experiment, using FNurse and actually looking at neural synchrony between the teacher and the learning and seeing how that is corresponding to the actual teaching behaviours that we were mapping. But it's going to be controversial, so there's going to be a lot of discussion and collaboration needed. Okay, I haven't got time for this, but just to say, if you start thinking about these different cognitive processes that teachers step through before they use research, it helps you understand why some tends to be more the educator-led research tends to be much more successful in terms of the uptake of the research. So, and this is just an example from Richard Church's. So I analysed Richard Church's research and actually thought, actually, this kind of makes sense as to why it worked and why it got taken up. It also tells you why bad stuff like Brain Gym gets taken up, because these people also hit all the boxes. And I think we can, I'm sorry to say, but I think we can learn from this. And I do remember going to Usha's conference, wonderful conference. Oh, when was that? How was that? 2005, was it? 2005. And I thought, all this wealth of knowledge, but you could also see that teachers were sort of a little bit put out by the whole thing, a little bit unsettled. I don't know how many of them went away and applied the findings. And I could see, even then, I was thinking, oh, this is going to be quite tricky. Then we went to Old Trafford football ground in Manchester, where 1,000 teachers had assembled to hear motivational speakers talk about brain gym and learning styles. It was wicked. We were there, myself and my psychologist friend, jumping up and down, singing, doing the movements. This is great. I want to go home and apply this. It's fantastic. You know, no, hang on. I think we have got something to learn in terms of bringing people along with us from these very dodgy salespeople. Yeah, teachers prefer to use research from brokers, not researchers. This is a fact. They might like listening to you, but they're not going to use it unless they hear about it from another educator. So one of the things that we are looking at now is podcasting, because teachers don't tend to talk very spontaneously to us just to have a chat so we can analyse their speech, but they do like being in podcasts, we've discovered. So we're doing a podcast on fingers and the use of fingers in early maths learning, and then we're going to use that to tell the story of the research we want to tell. It'll also give us a chance to analyse the difference in language between how teachers talk about research and how researchers talk about research. We are going to be editing, obviously, so it's a matter of how much editing we need to do, but we've got sort of very clear principles so that we can try to maximise as much as possible to use the voices of the teachers. But already, it's thrown up some interesting ethical issues, which I call Podgygate. So this one teacher said, and I think they were talking about the fact that young children have difficulty using their fingers, and they do need to be encouraged to use them and to get to know how to use them. And she said, oh, I think some children potentially have still got those sort of podgy fingers still. Can I say that? Actually, I do find it quite hard to manipulate or even... And I took this to my boss, Camilla, and she said, you're going to have to decide on this, because my colleague Colin was saying, I don't think we can use this, Paul. I thought, I'm sure we can use it. I'm sure it'll be fine. But Camilla said, no, we can't use it. So this is kind of difficult, isn't it? Because we really want the authentic teacher voice, but now we're being told, oh no, no, we can't use that actually. Okay, all I'm saying is this is not straightforward at all. We want to use the teachers' voices, but there's going to be things that are unscientific. Sometimes we have to make judgments. It's not going to be straightforward. But do notice that actually the reading level of this section is 12 to 13 years old. And that's the reading level that I was told to make my Royal Society report, the executive summary, anyway. I don't know if you've had this experience. That's what they say as the advice, you know. Make it reading level 12 to 13 years old. They've got it right. You know, whereas when you look at the research brief, which my colleagues spent some time preparing in the most accessible language they thought possible, actually, and it's not that, you know, it's not that bad, is it really? I can see why they thought that was acceptable. It's college graduate level. So I think that's quite interesting for a start. Anyway, in summary, and this is a very short summary, I think you know basically what I'm saying. I'm saying teaching. I'm saying teachers and teaching. That's the new frontier. We have to move forward and do that. Our ace in the hole is the fact that we are scientists and we can approach this scientifically. But let's not hold back and just study learning. Thank you.